All right, let's do another bearing problem. It says an airport B is 300 miles from airport A. Airport B is 300 miles from airport A at a bearing of north 50 east. So let's draw in our, I always try to draw, one of the keys to this is always drawing like a new coordinate axis at every point to make sure that you're keeping things straight. So it says A is north 50E. B is 300 miles from A at a bearing. Okay, so let's call this A. And it says B is 300 miles from A at a bearing of northeast. So north 50 east would be like this. And try to draw it to scale as well, as much as possible. So this is 50 because it's northeast, right? So that's north 50 east would be 50 degrees there. Okay, so there's airport B up here, and that distance is 300 miles.
Got it.
So this is 300 miles. Okay, then it says a pilot wishing to fly from A to B mistakenly flies due east 200 miles per hour for 30 minutes when he notices his error. So he means to fly from A to B. So he starts, use purple, he starts here, and instead of flying to B correctly, he flies due east. So he's going this way. Now, how far this way does he go is the question. Well, it says 200 miles an hour for 30 minutes. So how many total miles did he go?
500.
Nope, 200 miles per hour for half an hour. 30 minutes is a half hour, right?
Yeah.
So if it's 200 miles per hour for half an hour, he went how far? Half of 200.
Yes.
He went 100.
Yeah.
So he only went 100 miles. So again, draw to scale. So I'm going to erase this now, and I'm going to make it drawn relatively to scale there.
Oh, I had that. I'm sorry. I didn't
Yeah.
have that.
Yeah. So there you go. There's that. And he went due east. And now the question is, it says how far is the pilot? So make this light blue. How far is he from his destination at the time he notices the error? So they're asking about this distance right here. From there to there, they're saying, what is that distance? Do I have a right angle anywhere in here?
Nope.
No, but what do I have? Well, I have some angles. Let's draw some angles in here. I know that this angle is 40 because the other one was 50.
Right, I got that.
And I've got an angle, side angle, which means I have to use law of
Sines.
cosines because I don't have a side across from an angle.
That's what I meant.
I have to use the law of cosines. So the law of cosines,
That's what I did, right?
yep, the law of cosines says, all right, so that's the law of cosines. And so we have A and B and we have angle C, and we can just literally plug all that stuff in. So C equals the square root of 100 squared plus 300 squared minus 2 times 100 times 300 times the cosine of 40. And when we solve that, we get 232.5 exactly. I mean, pretty close to that.
It's rounded.
Rounded, okay, we rounded it. So that's that many miles, so that's how far away he is. And then the question also is going to be on what bearing should he direct his plane. So we want to find, and this is usually the harder part for people, we want to find, so what I like to do is, again, I draw in a new coordinate plane right here. See how I'm drawing in a new XY plane right there? It's tricky with this to get this straight line. Let me just manually draw the straight line in. So there's my new coordinate plane drawn in, and we want to find out what this angle, that tiny little angle, is right there. Well, in order to find that, we need to find this whole angle right here. We can use the law of sines now, and once we find that angle, we subtract. If we drew this to scale correctly, we would subtract 90 from it.
Yes.
And that angle would be north, whatever that small angle is, east. When we
north 34 east.
So let's go ahead and find that. Use the law of sines.
Okay.
So we want to use the law of sines says that the sine of the angle that we don't know, which is C, is equal. Actually, it's not C. Well, whatever. It's this angle over here. I guess it would be C, but I use C over here for something else. But again, it doesn't matter. The sine of C over 300 equals the sine of 40 over 232.5.
Okay.
And then solve that for C. So punch that in. So when you get this, your answer is going to tell you in your calculator. It's going to tell you 56.0375. I'm rounding in a little bit there, but you know that answer is bigger than 90. So really, what you have to realize is that there's you have to subtract. It's the ambiguous case. You have to subtract that from 180 because the sine of the sine of that is the same as the sine of this over here, and that's the angle that we want. So instead of that being your answer, do 180 minus that. So 180 minus that answer is going to give you, and you get 124 when you do that. So 124 is your answer, but we're still not done because that's not the bearing. Now we got to subtract. So this angle is 124. But we want to subtract out 90, and that's going to give us the bearing. So subtract 90 from that.
34.
And there's your 34, north 34 east. There might be an easier way to do that problem. Maybe the easier way to do it would have been to find that angle, which was 16 point something, and then just add those together and subtract to find that third angle, 180 minus those things. You could have done it that way too.
That's the way I did it.
That way would have worked as well.